you doing today? Good? Yeah? Great. So my name is Andy. So I work for KUKA. How many of you are familiar with KUKA? Some? Okay, so KUKA, we are a German company. We make automation equipment, so we make robots. And we actually work a lot in automotive, aerospace, and other industries. So today I had the pleasure to kind of talk to you guys a little bit about factory of the future and what does that really mean. So a couple of slides just kind of talk a little bit about some of the motivations. You guys probably know this already, but if you look at our world today, how many of you have one smartphone on you? Probably all of us. How many of you have two? What about three? Yes, I love it. There's always at least one person in the room got 3 connected devices on him. But that's the truth. I mean, this is really, wait, 6?
They're going to say connect, you said phones.
Well, I say smartphones, right? Watches, yeah? So all of this, I also have a Fitbit, you know, I have a smartphone on me, but a lot of devices now are getting smarter and smarter, and they're all connected, right? And that's just on us. When we go home, we have Nest, probably. Maybe some of you have Alexa or some of the other consumer equipment that you have in a house. It's fascinating to see how connected our world truly has become, right? And if we look at the progression, what fascinated me the most is 90% of the world's data actually been created over the last 2 years. And think about that for a second. That's a tremendous amount of data. We're talking about, in 2016, 23 billion zettabyte of data, and 90% of those was created over the last 2 years. I mean, that's fascinating. Now, a lot of people look at this data as an opportunity, but there's also a lot of challenges, right? And specifically, when we look at manufacturing, some of you probably have heard of the term Industry 4.0, potentially, right? It's a European term that talk about the progression in automation. Back in the 1780s, when we started to do mass production, we started with gearboxes and steam power machines. And then we fast forward to today, we have computerized automation technologies, we have tablets, we have mobile devices, and it's just going to continue, right? We're going to continue to introduce this new set of technologies like cloud, web, and mobile into our manufacturing, into our facilities today. But where are we really going? What is really the goal that we're driving towards? So there's this concept within automation industry, it's called matrix production. How many of you have heard of this term before? Couple of you. So matrix production, if you think about manufacturing facilities today, each robot is kind of like this mic. It's mounted in a very fixed position, and the robot is commissioned to do one thing really well, whether it be welding, gluing, pick and place, and that's it. And that machine is going to do that job for probably about 7 to 10 years, right? Depending on the life cycle of the product that the robot is producing. In automotive specifically, usually 7 to 10 years. But as we all know, the products that we have as consumers today are changing very drastically, right? I used a phone example earlier. I mean, iPhone changes their product once a year, right? Samsung is probably faster than that. And new products now are really driven by consumers, driven by you and me as consumers to continue to have more customizable products, and new technologies are embedded into these products. So what does that mean for the manufacturers? They have to change very quickly. They have to adapt to new technologies. They have to retool very frequently. So having these fixed-base robots that only does one thing for an extended period of time, it's not scalable anymore. So the vision of factory of the future or matrix production is really leveraging mobility platforms. So a robot can now actually drive around within the factory. The robot actually has 10, maybe 20 different personalities or different application processes that they could do. And depending on the demand and depending on the application, they could reorient themselves to perform that specific task. And that's very important. But how do we get there? Well, we talk a lot about big data analytics, even learning. Data is really the new oil now. Data could actually help us to derive a lot of new insights. I mean, even if we're sitting in this room right now, there is a light, there's a temperature, there's my voice, the sound. There's a lot of data that surrounds us even here in this particular setting. And if you put yourself in factories, there's a lot more data that exists, right? And a lot of those data are actually not being captured A lot of those data are actually not being able to relate the right relevant information for us to understand exactly what's happening. So in manufacturing, I talk about matrix production is really the vision. There's a lot of data that we should all be thinking about. And for us, you know, some of the things that we're very curious to understand is what happened to my assembly line, what happened to my robot, why did it happen, but more importantly, what's going to happen next, and how do I continue to improve the results, right? So in our industry, we talk a lot about analytics, and it's mostly about the machine health, right? How do we make sure that these equipments, these robots, could be running 24/7 as efficiently as possible? And this is really some of the things that we as KUKA, as a company, are trying to develop right now. Now, we can't really do that alone. I mean, I mentioned, you know, we are an automation company. We're really in the beginning stages of smart factory, literally transforming data into relevant information so that we and/or our customers can make the right decision based on those informations. But ultimately, we want to get to a point where the machines themselves could actually make optimizations, they can make decisions on the fly, and you know, when I talk about those matrix productions, the robots can make the right intelligent decisions to reorient themselves, right? And if you take a step back, and if you think about, you know, the Enterprise Summit today, we're talking a lot about these new 5G or wireless technologies, right? And to me, that's a very, very important piece. It's a very important foundation for us in the automation industry to be able to get to smart factory or the factory of the future. So we're currently developing a set of products. It's a cloud-based product called KUKA Connect. But one of the things that we're very excited about is actually working with partners like yourself and others to continue to push the cloud-based ecosystem forward. So there's going to be a lot of infrastructure needs to make sure that we have the right bandwidth in the factory. We can actually abstract all the data that we need. But more importantly, we need to work with partners to be able to analyze these data to make sure that we can continue to optimize the processes, to be able to do things like predictive maintenance, to be able to do service, and everything surrounding the machines themselves to make sure that those things can run as efficiently as possible. So I actually just want to keep the presentation relatively short because I know that we're short on time today. But is there any question from the audience? Yes?
What wireless protocols are being used to communicate to the machines?
So right now, we're actually not using any wireless protocol right now. We are exploring working with different service providers to try to understand what would be the most relevant wireless protocols. I mean, people talk about 5G a lot, so we're thinking about going into that direction. But again, this is something that I think the infrastructure and the service provider will provide us as the foundation platform. Any other questions? Yes?
So, if I understand it correctly, you're backhauling data out of a factory site to somewhere in KUKA's infrastructure in private cloud or public cloud?
Private, yeah.
Okay. So, implied there is that you're opening up really interesting attack vectors in the robots in the factory. So what's your approach to protecting hackers from getting in there and having fun?
Yeah, that's a very good question. So data and privacy is obviously a very huge concern. And I would say that in manufacturing specifically, the adoption of new technology usually it's a little bit slower than other industries. So right now, the approach that we have taken is that we only enable one-way communication. So only data could go out, but no data is coming in, right? And if you think about factories today, the way that they set up their infrastructure, they have a production network, which is completely isolated from the corporate network. So all the data that we could collect is all from the production network, but the only way to get the data out is through the corporate network. So there's a virtual firewall and also physical firewall built in to some of these edge devices to make sure that we isolate the two data and the two network completely.
I guess a follow-up on that. So GE was talking earlier about their digital twin concept and being able to take learnings from multiple devices, draw bigger picture learnings from them in the cloud, and then reapply them back to the individual lot unit of one. That seems to be out of the picture for KUKA at this point. based on that, what you just described?
So as of right now, yes, but I think that's the direction that we would like to go. I mean, technologically, there's nothing stopping us from doing that, right? But we have to also face the reality of the uptake from our end customers and just manufacturing and factories in general. We need to do a better job at educating them on some of these cloud-based technologies to make sure that they feel comfortable and confident, so that they don't worry about, hey, I hear about somebody being hacked, or how's my data being secure, or and things like that. So I think we as a community just need to do a better job to make sure that they feel safe, they feel confident with these set of technologies.
But at the same time, I mean, you want to also do a lot of controlling. So there is a lot of this data that you're collecting and that you're taking out. It also needs to be used to, as you say, to actually manage whatever you're managing. So is there a risk that you have to collect the same data, use it in different ways, and is there a risk of duplication? Because I cannot imagine that they just want to collect the data and look at it after the fact. They also want to use it in real time.
Right, so right now it's about collecting the data, transforming them into information so that human, like a factory worker or the production manager, could make the right decision on the fly. So it's not automatic, right? So human is still in the loop. We're just simply providing them with much more visibility into what the machines are doing by being able to extract those information out.
Okay, there was another question. There was another question back there. Yeah. And
I wouldn't mind hearing your opinion, Andy. Just kind of go back to the first question. What's your opinion on is there a place for wireless, whether it's LPWAN or whatever? I don't care about in smart factory. What's your opinion?
There definitely is, and I think people talk about, well, is it Bluetooth or some other wireless technologies? Me personally, from my conversation with some of these end users, I think Bluetooth is not really something that they would consider, just because it's a really harsh environment. But definitely wireless technologies, people are talking about even building these wireless chips onto the PLCs, for instance. So there's definitely a lot of discussions now within the industry about introducing wireless technologies into the nodes or the cells themselves.
And KUKA, you're looking at that as well?
Absolutely.
Thank you.
final question, I believe. Yes.
So you're collecting data, it's fairly low latent activity. Do you also see, given these are robots, that there's a future in actually very low latency, more control going on from a separate, maybe I won't say cloud, but from a server?
Yeah, so the architecture, I mean, we didn't have a lot of time today to dive into it, right? So we have the devices at the bottom. We have edge, or people call it a fog layer, and then we have the cloud. So we definitely see the paradigm where we want to be able to leverage the cloud to do analytics, learning, and some of the more computationally intensive algorithms and processes. Be able to push down some commands to the fog layer and leverage the edge computing to actually do some local processes and then distribute those things back out.
So closing on that then, because a lot of questions about wireless connectivity, wouldn't reliable standards-based wireless connectivity with options for low bit rate, low latency, high bit rate data collection be really the right answer for
Yes,
what you want?
it would be. Yes, it would be. If it exists, we would use it.
The wireless connectivity was the big question.
So my comment back to him was high performance, ever higher performance edge computing is rolling out in the same time frame as 5G. I mean, we're going to have very significant compute capabilities at the edge, obviating a lot of the need for cloud-based computing in many of these environments, especially for life-critical, real-time operations. So, I mean, it's not, from my perspective, cloud isn't the panacea. And 5G is still 5 years.
Right. Yeah, I think to me it's we're given a lot of different tools in our back pockets now, right? You have a lot of different processes down from the robot level. We have robot controllers to the edge, to the PLC, to the fog, to the cloud. And I think for us as a community, I think we're still trying to figure out which layer is best suited for what applications, right? And like you said, there is a time horizon issues, right? Some technologies are readily available today, some maybe 5 years, 10 years, 20 years down the road. I think we just need to figure out the best way to implement some of these technologies today and learn and iterate from
I guess that if I can comment further on this question is that it seems like in this whole thing, the bit that is really complicated is actually the analyzing part. The edge computing, the wireless connectivity, that's actually figured out. I mean, I guess that's my view on this. It's like the technology is actually there. It's the analyzing that is the difficult bit. So it just seems that what I'm hearing from you is the other way around.
It's
so
yes and no.
I'm trying.
Yeah, because yes, data exists, but data exists today. They're not time synchronized. They're not time stamped properly. So for us to do analytics,
that's the difficult bit.
Right, we have to figure out how to uniform.
If you take that approach, you could say they're all there today in some aspect. We do analytics today in various forms. We got new data sets coming out that you're going to do a new level of analytics on. We've got wireless connectivity and a wide-ranging set of types of it, but we've got new applications for wireless connectivity with high mobility of variations of different data streams and a variation of different latency needs. So I think the whole stack is being addressed in very new ways. I think it goes beyond just the analytics.
But the analytics is the part that we really have not figured out. I mean, not that we have the tools to do it, but you know, in terms of maturity, we are less, as a sort of an ecosystem, I would say we are less mature in the analytics part than in the wireless connectivity part. I don't know, maybe anybody have some different ideas.
I'm Otto Hernandez with Verizon Wireless, and I serve the public sector, and public knowledge that there's automated vehicles running in our country today, and that is a combination of the cloud and the edge working together, making split-second decisions with the car going 70 miles down the road, being able to make decisions on the fly where it is and how to change. So really, it's a merging of both, being able to go back to the cloud when you need to, but at the same time have enough analytics at the edge to be able to make literally split-second life decisions, and it's happening today. I mean, I don't know if you guys heard. I think it was last week. There was a self-driving Uber car that was in an accident. It was on Google. It was on Yahoo and everything else, and it was determined by cameras and witnesses that the other person ran the light. So the Uber car doing the defensive mechanism at that point was still in infancy, but they were able to make some decision to not have the accident be worse than it was, and the actual human was the one that was involved. So it's really a combination of both.
Absolutely.
Okay, I think we need to move on. It's a very interesting conversation.
Right. Thank you,
Andy,
guys.
thanks a lot. Thanks.